It's been a minute since we've talked about new advancements in generative AI, specifically for images. Obviously, Stable Diffusion has massive advancements like Stable Diffusion XL. There is Stable Video that has now been released with 2 separate versions. And Stable Diffusion has seemingly been fine-tuned and lured into so many different things that it seems like there's nothing you really can't do with it at this point. But Stability AI is still committed to their mission of forwarding research in this area. And yesterday, they dropped something that is very new and that I think isn't being talked about in ways that it should be. This is called Stable Cascade. It's built on a brand new architecture. I think it rivals the capabilities of Stable Diffusion XL, DALL-E 3, and explicitly Midjourney version 6, but I'll get into that in just a bit. So welcome to AI Flux, let's get into it. So this new release from Stability AI is a little bit different, and this new model they're announcing is called Stable Cascade, and the big deal with this model is that it's not built in the ways that every version of Stable Diffusion before it was, and it's why it's actually not just a version of Stable Diffusion. It has its own name, Stable Cascade. So I want to get into the technicalities of this in just a minute, but basically the architectural basis of this is that it's based on building upon some research that was done previously that's referred to as the Worston architecture. Right now, it's being released kind of as a research preview from Stability AI in a non-commercial way. So what's interesting is, in short, the biggest advancement and the biggest advantage to this new architecture that Stable Cascade uses is that it's exceptionally easy to train and fine-tune on consumer hardware. And they refer to this being the case because of its 3-stage approach, which I'll get into in just a bit. The idea here is it allows much more fine-tuning and community engagement with less hardware. And it, obviously Stable Diffusion and Stable Diffusion XL, it meant that you could, these were models you could fine-tune without too much power. But if you had a really small GPU, like anything smaller than, say, a 3090, it would either take a lot of time or the amount of purchase you would have on these models in, creating LoRa's or doing fine tunes was pretty limited. And I think it's cool that Stability AI is clearly showing their direction and their focus here in making this available to more people, especially without expensive rented GPUs. And what's really cool is they're actually providing all of the checkpoints and inference scripts on day one, when in the past we've actually had to wait for these. And they're explicitly releasing scripts for fine-tuning, ControlNet, and LoRa, basically to enable users to further experiment with this new architecture because they want to see if this is working. So it reminds me of some previous videos I've made with other research previews they've done that were fundamentally different. Another great example of this is when they released models that sort of teased the idea of having 2 different models working together, kind of like early versions of Stable Diffusion XL. So what's cool is this is taking a similar approach with a vastly different implementation. So how does Stability AI describe this? Basically, they describe Stable Cascade as this. So they said this innovative text-to-image model introduces an interesting 3-stage approach, setting new benchmarks for quality, flexibility, fine-tuning, and efficiency, with a focus on further eliminating hardware barrier. Additionally, we are releasing a training and inference code that can be found on their GitHub, which I'll link below, to further allow customization of the model and its outputs. The model is available for inference in the diffusers library. And now for some technical details. So what's interesting is, at a high level, they pretty much say that Stable Cascade differs from Stable Diffusion in that it's built on a pipeline comprising of 3 distinct models. And early versions of Stable Diffusion XL used 2. So this is the use of kind of a primary and then refiner model to add additional context and resolution and kind of detail finishing. So they refer to these stages as A, B, and C, and they say here that this architecture allows for hierarchical compression of images, achieving remarkable outputs while utilizing a highly compressed latent space. So the key here really is how they manipulate latent space and kind of use it. And basically, there are still 3 very common elements here, which is a diffusion model in stage C, diffusion model in stage B, and a VAE in stage A, which curiously, the way you work through this is from stage C to stage A, with the resultant image being there. You can see the prompt coming in here, an armchair in the shape of an avocado, and then the image coming up here. So where in terms of research is this coming from, and what is this new or existing kind of Worston architecture? So this is actually research that came out relatively recently, it was published on January 16th, 2024, and last modified on February 10th. So the kind of thesis of this research is pretty interesting. So right here they say, it's mostly focusing on latent diffusion models, in text-to-image generation, and they say, we propose an efficient text-to-image model that only requires 1/8 of Stable Diffusion 2.1's compute budget for training and has comparable, if not better, image quality with less than half the inference time. So what's curious is it makes sense why Stability AI went after this research, because the entire goal of these researchers was to create and train a model or create an architecture that used 1/8 of Stable Diffusion 2.1's compute budget. So they're aiming at compute explicitly, and they're aiming for better image quality, which initially would seem kind of nuts, but obviously this worked. Pretty much, they mentioned cost effectiveness for large-scale text-to-image diffusion models, and most of their work was around this new latent diffusion technique, as they refer to it. This is sort of a compression play. It's basically a way that you can memoize or kind of have a more efficient lookup table for some of these weights and then pass them through stages and in effect have better results with much less raw compute required. Because they mentioned here, this is a highly compressed representation of an image that provides more detailed guidance to latent representations of language, which is referring to the VAE. And what's interesting is they say our approach also improves the quality of text conditioned image generation based on their user preference study. To train this model, it did take a lot of compute. So ironically, in order to create this new novel architecture, it took around 24,600 A100 GPU hours, so that's a lot of A100s. The difference, I guess, here is they don't mention what GPUs were used for Stable Diffusion. I assume A100s since they use AWS. But they mentioned that it actually took Stable Diffusion 2.1 200,000 GPU hours to train. So what's curious is it actually took less compute to even train it. There's no way I'm ever going to be able to afford 24,000 hours of A100 GPU time, but I hope in the near future we maybe get there. And the other thing they mentioned is on top of having less compute, it required less data. And this furthermore looks into their compact latent representations that allows for all of this to be possible and compete with current state-of-the-art models. So how do these actually work? So the biggest thing about this model is speed and efficiency. Architecturally, Stable Cascade is still really interesting, but it doesn't change much under the hood except for possibly being trained on a better data set. So better data, again, is going to give you the biggest gains in basically anything you do with AI. The magic is that the latent space is really small and compressed heavily, which makes the initial generations really fast, and the second stage is trained to decompress a bit and basically upscale or detail from these small latent images. And the last stage is really similar to VAE decoding, and they even call that basically a VAE. The second stage is a VQ GAN, which might be more exciting to researchers than most people watching these videos, and this is kind of a new area of research that potentially could open up new ways to edit or control images within just that step, so not even after it's been completely finished. So roughly, in terms of data, we know that this listens to prompts about 10% better. The aesthetic quality is just legendary. This is why I compare it to what you can currently get from Midjourney version 6. And the cool thing is it's faster than SDXL Turbo, which I've shown in videos before kind of as B-roll. I'm also working on a project called Attention Cube with WebGL, and I'm going to be using Stable Diffusion Turbo, but I actually might use this now because basically it's a revolving cube rendered in WebGL that has images rendered on each side that are generated in real time. I'm using it for entropy, but if you're curious, let me know in the comments and I can maybe make a video about it once it's done. So how does it actually compare to a bunch of other image models, at least when we look at SDXL and SDXL Turbo, since I just kind of brought this up? When we look at this, we can see that SDXL Turbo is actually still behind in terms of prompt alignment. And even with SDXL, which is just focusing on accuracy and detail in general, we see that Stable Cascade still massively outperforms it. And what's really cool is Stable Cascade is clearly still its own model, because when you compare it to Worston v2, which is the actual result of the model of the research I just showed you guys, it's still vastly better. It's almost 3 times as good at least in terms of prompt alignment. Aesthetic quality is pretty objective, but it's cool that we actually have sort of a way with data to measure this. Obviously, there are some massive differences here when we look at SDXL Turbo versus Stable Cascade. SDXL Turbo, in my opinion, took some pretty major compromises to achieve the speed that it did, and it's really cool to see Stable Cascade be that much better, to the point that I'm probably just going to rip out my implementation of SDXL Turbo in that Attention Cube project. And what's also really cool is even when we compare SDXL and Worston v2, the aesthetic quality is basically a 2, if not a 3x improvement, which is really cool. And I'm gonna mess around with this and obviously show you guys some examples because you're gonna be the actual judge of whether this looks as good as they claim it does. But I think this is pretty cool. And the other thing here is just the wild inference speed when we look even at batch size 4. And what's cool here is they actually break down the stages at play as well. So we see the first stage, C, taking about 6 seconds, and the last one here taking about 4 seconds. Obviously, SDXL Turbo is able to create an image in basically 1 step. So yes, it is still faster, but in terms of how well you can parallelize this and what you're actually getting at the end, this is pretty crazy. Stable Cascade takes about half the time in terms of raw inference, and I wouldn't be surprised if we get pretty close to what SDXL Turbo can do. The researchers at Stability AI aren't too shy about this. They say Stable Cascade's focus on efficiency is evidenced through its architecture and higher compressed latent space. Again, the huge speed up here is totally based around how latent space is being accessed and represented in memory. Despite the largest model containing 1.4 billion parameters more than Stable Diffusion XL, it still features faster inference times, as seen in the figure below. And the one thing that hasn't been mentioned in a lot of videos that cover this are the additional features. So what's really cool is Stable Cascade can actually generate variations in a much more nuanced way. And the reason it can do this is it can actually change within its stepped pipeline what's happening within the pipeline as opposed to just running multiple times with similar inputs. So basically, image variations work by extracting image embeddings from a given image using clip and then returning this back to the model. And here are some example outputs. So the variations is great, and also image to image is great. And what's cool is when you have a multi-stepped model like this, you can make changes in one earlier stage and not run it through the entire model again, which means you maintain consistency much better. Here, image to image works by simply adding more noise to a given image and then using this as a starting point. And you can reference a starting point kind of deeper in that process than you could in the past. This model is also really, really good at outpainting and masking, which I think was kind of interesting because I wouldn't have expected that. If anything, in some of these research models, you lose some features, but this one seems quite good. Another thing that Stability AI has been big on is generating an image just on edges, which is basically saying you're feeding very little input into the initial clip and then seeing what it actually does with it. And this model obviously is very, very good at following this. Curiously as well, this model, since it's so good at image to image, I guess not so surprisingly, is pretty good at upscaling as well. So they call this 2x super resolution. And pretty much this is, taking an image at 1 resolution and then massively increasing it. And previously we thought this was something that was really a specific strong suit of SDXL. And clearly this looks just as good. You can get the weights right now. You can also try it out in theory on their developer platform, although you can't really use it commercially yet. So really cool stuff with this research. There's also an unofficial demo already up and running. So let me see if I can put something in here. And there we go. So the demo is cool. The resolution, frankly, is a little bit limited, but it kind of makes sense. However, the idea that this is running on a full-size GPU and is actually kind of a reasonable GPU at that, it's pretty cool that that just worked in less than 10 seconds, which is pretty awesome. So let me just modify this a little bit so I can show you guys how fast this is when it doesn't actually have to fetch a GPU. And I think we can get this other one done in a little bit less than 10. Now, I will say the one quirk with this that I found is that sometimes if your prompts are a little bit too similar, it seems like this model has a harder time actually differentiating. So I just went from squirrel to Soviet squirrel. So there's a Soviet squirrel, but still quite similar. And yeah, so let me show you some actual examples here, and you guys can let me know in the comments what you think. And you guys can tell me if you actually think this is comparable to Midjourney version 6. So here's the first one. So the left is Midjourney v6, the right is Stability Cascade, and I think these are pretty good. Granted, Midjourney v6 edges out a little bit better when it comes to bokeh and just basic lens aberration and focal length. I think I would still pick the one on the left if I had to pick one of these. However, Stable Cascade is still quite close. And one thing where I think Stable Cascade really shows its prowess is in line work. And you'd think that Midjourney would actually be better at this, but I think in terms of understanding, what a flower petal is and then understanding kind of the line work you want, Stable Cascade clearly wins out here. Now, in terms of vector art and logos, I like Midjourney V6, and I've actually used Midjourney for this quite a few times for this. However, I do still think that the cohesion of Stable Cascade wins out here. And this is just one example, but it's interesting to see. Now, this is an example where it's really, really hard to pick a distinct winner. Unsurprisingly, a lot of these models now actually perform better if you give them less prompt input, because you're leaving more for the model to work out and kind of choose for you. So you can see in both of these, there are vehicles, there's rain on the road. We're getting this reflection back off, so the kind of thing that in previous years you would have actually had to ray trace the entire thing. I will say my eye seems to carry a little bit more and have a stronger focal just alignment on the Midjourney image, just because there's more in it. And because you see you have the bokeh of the buildings, and you have sort of the linear perspective that this is a long street with buildings that go on and on and on, whereas Stable Cascade went seemingly for a smaller scope and just gave us an alleyway that has a lot of similar attributes. Now, I will say, the lighting is harder to get right under this awning, but I'm curious why there's kind of some red light here. Fortunately, the umbrellas both look pretty shaped as they should be, and these are both pretty impressive. So what I'll say is Stable Cascade, when given the right inputs and the right situations, I think can easily match what Midjourney V6 can produce. However, I think Midjourney V6 is still better in more of a general sense. And clearly that's the case because Midjourney V6 has some of the highest user throughput of any of these image generation models, which means they have some of the best feedback and the best idea of what the human eye likes to look at, which granted, I think in a lot of cases isn't what maybe every user wants, which is where Stability AI comes in with their models, which gives you tons and tons of control. So what I can't wait to see are comfy UI setups with Stable Cascade that allow for an overwhelming amount of control, now actually within different points of inference and image generation, which I think will be very, very cool to see. And we've already seen this with even things like Stable Diffusion XL. So are you guys gonna try this out? I'll link to everything below, including the demo and the weights as they've been released by Stability AI. Are you guys gonna use these? Has anyone built a comfy UI flow? Does anyone else have kind of a cool project that they needed a very fast image generation that was capable for something like Stable Diffusion Turbo or Stable Cascade? Let me know in the comments below. As always, I hope you learned something, and if you like this video, please like, subscribe, and share. And we'll see you in the next one.